Okay, I think all the streams are going. So today I wanted to work on a new project. It's something that I've been like thinking about a lot over the past like 3 or so weeks. And it's a project I might have actually have source code for it already. Let's see here. Trap. Did I start this thing already? Yeah, VMViz. Probably don't have much here. Yeah, just a Excalibur. Maybe I start writing some code. The basic idea is like I want to have a program that I can attach using ptrace to any other program in the system, and then it basically visually shows the maps for the process, the virtual address space with all the maps, and you can kind of like drill into the maps and see the actual memory, the data stored in memory, and some other features I would like to add is like real-time updates. So every time ptrace intercepts execution of the program, it can like dump the memory of the maps that you're like inspecting and store that in the memory of the tracer and do a diff, and whenever there's changes kind of indicate visually that there's changes to those memory addresses through some like fading colorization or something. And then also being able to like select ranges of bytes and interpret them as different data types like strings, numeric types, structures from header files, and then also like consulting the dwarf information and being able to like automatically do that, and even like doing that for things that are just like conventionally known what this data means. I think that'd be a fun little project. So yeah, that's kind of like the big idea. And then I wanted to use, what is it called, Raylib to do it, because I've heard a lot of good things about Raylib. So that's kind of all the ideas that I have going into this. So Linux only, ptrace, Raylib, visually display the memory of the process, basically. TLDR, and I don't even know what I have in this docs directory. Let me poke in there, LA docs. So there's an Excalibur, and I was using this the other day for something that I forget what it was. Oh, this was probably that. I'm just gonna save this, save to file, and we'll just say temp, and we'll just throw it on the desktop maybe. Is there a desktop here? Yeah, it should be. It's odd that it doesn't show up over here. Put it over here. New bookmark, desktop, bam. So just save that, just in case. So that had user to screen, tracer process, all that. Okay, so let's do an open, load from file, and I'm gonna pull from, let's see, home, source, there we go, GitHub, trap, and then VMViz, there we go. And that has same thing. Okay, so there's a little bit more effort put into this diagram than what I just explained, but we have our tracer process, so I might just start that here and say vim tracer.c. So the tracer process is the main process, and it's going to use ptrace to trace a specific process by PID, or I guess it could do the exec. But anyways, it's going to use ptrace to trace it. When the tracer has control, it'll use this process VM read v to read data from the traced process into the tracer and then do a diff against it. which means that we'll have to have twice as much memory in the tracer to be able to do the diff. So I don't think you can like, yeah, doing the diff is challenging. Computationally going to be expensive, but the whole idea of this program is that it's not obviously not a performance tool. Like it's gonna be slow. It's gonna be like the program and the UI itself should not ideally be slow, but the program that is tracing is going to have a lot of time where it's not being executed, basically, because the tracer has to do work. So I guess that's like to kick it off. We probably should have a separate thread for updating the UI and a thread for handling all the ptrace stuff. So this model is probably not the model I'm going to end with. But we'll see. I think what I want to do, so let's go ahead and just reset the canvas so I don't have to, and then I can actually RM desktop temp. I don't need that. Excalidraw. Okay, and then here, I think what I want to do is, well, first I have to pound include, what is this, standard lib.h, get that thing, little header definition. Okay. I guess the first thing I need to do is make sure I have raylib on this thing, right? How do I find raylib? Pacman raylib. Okay, so we got raylib. I'm not going to vendor it. I'm just going to use it off the whole system here. So my first program here, what's going on here? Tracer. Actually, you know what I'm going to do? I'm going to copy tracer into drawui.c. And you know what? I'm going to do something that's a little bit unconventional here. Actually, you know what? I'm going to mkdir source mv star.c into source. Then makefile. All is going to be the draw UI, and this would be under build, and we can echo build into .get ignore, and I'm actually just gonna copy from a different make file. What I've been working on recently, the parallel computing course. I think the last thing I worked on before that was CSAPP, chapter 9 makefile. Just copy that here. Then makefile, all clean, all will have build, what's this thing called again? Draw UI. And we can delete that. Clean. Source. ZigCC standard C23 G OG. No sanitize, outputs, and source. Okay. Okay. Make clean. Make. Echo. Build. Build draw UI. Okay. Okay, jobs, no. Vim, source, draw, yeah. Alright, so in here, I want to basically get the whole, like, thing going with, like, draw a basic UI with a window and boxes in a window displaying values from a memory buffer. So that's what I want to do in this. I think I can just say, hey, you don't need any of this. Return, exit, success. And then, alright, so let's get the raylib documentation up here. Unless there's like man raylib. No. What is a terminal command to find the .so for a given library? LD config p grep for raylib libraylib. I love how lib is in there twice. Okay, so we got these SOs. You get 600 and you got the regular SO. If we go under user lib ls grep for raylib. So this maps to 600, 600 maps to 6000. So that is the actual shared object there. Okay. How do I read raylib docs from the terminal on what is Arch Linux? Pacman QL raylib. Okay. So we got header files under include. We got some CMake stuff going on here. We got our shared object. We got package config. I think that's a Archie thing. And then we got a license. Okay, there's a header file, so we could pull that in. There's gestures and cameras. We're not going to need any of that. Maybe the ray math we might need. But then there's raylib.h. So if we vim up, oops, that guy. Go down here. How many lines is it? So that's 1700 lines of header file. I'm gonna say no to reading all the header files. Although it's not too bad. Most of the function definitions are down here. This is all structs, constants, and then docs here. This is a simple and easy to use library to enjoy video game programming. Features no external dependencies. All required libraries included with raylib. Multi-platform. So that's something like if I have success in building this on Linux, it would be nice to be able to port it to Mac OS. I have no interest in porting it to Windows or anything else really, but Mac OS would be fun. But I don't think ptrace is available on Mac OS. They have some other like debugging backend. Is ptrace on Mac OS? So they have it because it comes through Unix. But what is the name of the preferred debugging interface on macOS? You have something else. Mock task thread API? Huh? Mock VMware. Okay. Just seems like it's just a pain in the ass to get it to go on Mac OS. Debugger entitlements, code signing, disable hardened runtime on the target, developer tools and permissions, SIP allowances in some cases. Okay, well, we'll cross that bridge when we come to it, but it is nice that it's supported by Raylib. Written in place C code, C99, in Pascal case, camel case notation. Hardware accelerated with OpenGL. In modern C 23 code bases is snake case more common than camel case or Pascal case? Macros, constants, upper snake case. Yeah, I mean that's kind of what I've ran into mostly in my use of C. C++, Java, C#, JavaScript. Okay. Hardware accelerated with OpenGL. Choose that compile time. Software render optional for systems with no GPU. Custom GL abstraction layer used as a standalone module. Multiple fonts. Format supported. Many texture formats supported. Full 3D. Support for 3D shapes, models, billboards, height maps, and more. Flexible material system. Supporting classic maps and PBR maps. Animated 3D models supported. Skeletal bone animations. Shader support, including model shaders and post-processing shader. Powerful math module for vector, matrix, and quaternary operations. Audio loading and playing with streaming support. VR stereo rendering with configurable HMD device parameters. Dependencies. Our core depends on the selected platform. Check our core C header for details. RLGL glad slash or glad underscore GL ES2. What is ES2? See, ES is ECMAScript in my web programming mind, but if we go over here in game programming, OpenGL, what is ES2? OpenGL ES2, okay. Embedded mobile device, okay, so that's for phones basically. Oh, okay. Our audio. Oh, what is this? STB rect pack? Rect pack. Oh, this is that STB guy. He creates like the single file header things. What is rec pack? Is this the same guy that like it did Raylib? Nothings, Sean Barrett. GitHub. No, this guy RaySand5. Okay. But what does a rectangle packer do? What does a rect pack do? Font glyph atlases. sprite sheets, light maps, UI atlas generation, packing images. So it's like a kind of like a sprite thing that you might use in web or UI or game programming. Okay. All the STB stuff is in here. I wonder if his middle name starts with a T. Perlin. Okay. He's written a lot of cool stuff. He's probably like a gangster programmer. I've used his hash map for some stuff, but it seems like he's got a lot of stuff in the SDB library. Okay, let's go ahead and quit out of here, and we're going to quit out of here. Okay, that's not very helpful. Let's get up examples. I wish they had a dark mode on this website. It's annoyingly bright. Okay, let's just go through the basics. Yeah, I guess we want to determine what the width and height are, right? At least the initial width height. Let's go ahead and do a func up here. Void create window, and oops, we'll just say const init width. So go to 800, and let's say I think it's const auto, right? Auto. We need our CP. Oops, CP. I want to do our what's it, dot cling. Yeah, cat dot cling. Yeah, there we go. And then init height. (1024) by 768. And then down here we can just say init window, init width, test. Still can't find raylib.h. User include grep raylib. It is raylib.h. Maybe it needs to go down here. Pound include raylib.h. I'm doing that. It's installed on the system. Clean. Oh, maybe I gotta call that for it to pull it in? I don't know. Well, source draw UI. I don't think it needs to have that. Cat source draw UI make clean make see if ChatGPT can figure that out. Okay, that's right. No link against it. Make file. And then this is going to have dash L lib ray lib. Like that. There we go. Sorry. Build. Okay, I drew something and then crashed immediately. Makes sense. This is the process. Exits. Jobs. Okay. Let's go down here. So it goes into some infinite loop. It sets a FPS target. That's interesting. Maybe just do that down here. And then why was that misleading? Indentation statement is indented too deep. Oh, okay. There we go. And then, which is black. Dark gray. This would be what is this? X would be width, init width divided by 2. This would be init height divided by 2. Sure, light gray. Okay. And at the bottom here, we'll say we'll just close window. Okay. Alright, make and run. Look at that. Beautiful. Be nice to get this width and divide that in half as well. But does draw text, it gives you back this thing RL API. What the hell? RL API. If not def, define it. Functions defined as extern by default. Okay. Measure text. So that's centered. And if I go here and I say I want it to be 200, hello world. Looks like it's not resizable. It kind of glitches out one time. Looks like this is not a interactive editor. Alright, delta time. So drawing circles, moving them across the screen. Func x plus equals speed. Use a scroll to change the FPS limit, R to reset. Oh, it's catching up. So the blue one is entirely dependent on the FPS. Higher frame count means that you're evaluating the code for drawing it at a higher frequency. Speed is increasing at a higher frequency. Versus the code above is independent of the frame rate. So you can drop the frame rate really low and, oops. Huh. There you go. You can drop it to be like 7. It's just going to stutter its way over, but it's not going to change its speed. Overall, its speed is the same. Whereas this guy's actually going to change its speed. It's a pretty common thing to run into in video game programming. I've done like a few visualizations in the past where my calculations for like acceleration and velocity and position were all based on the frame evaluation, which assumed a certain frame rate, whereas this thing's get frame time times speed. So it's so if it was a 1, then you would add speed. So 60 frame. So get frame time basically is the fraction of the frame rate. So if it took 1/60th of a second to evaluate that frame, then it would be set to 1. It's kind of what I'm getting from reading this. Let's go open up the user. Actually, you know what? You just go up here, relib.h, and look for get frame time. Gets time in seconds from last drawn frame, the delta time. Then why is it at 60 seconds? sorry, 60 frames per second, they're at the same speed. Why is that? Wouldn't that be like multiplying speed times 0.02 in this situation? And then this would just be... That doesn't make sense. They're probably doing more work on this branch that they're not showing there. So let's go ahead and look at it. So we knit our screen width and height. Oh, that's one thing I wanted to see is where does this string go? It goes nowhere. Let's just look for a knit window here. A knit window. Excuse me. This isn't really good documentation. It's just like a single line comment. So current FPS is 60. And then we have some structs here. A vector 2. Where do we get vector 2 from? It's not a Ford declaration. It's part of the library. Vector 2. Yep. So it's just a 2-component vector. Float vector. So we say the delta circle is the screen height divided by S the Y component, screen height divided by 3, and the frame circle is the screen height times 2 divided by 3. And they forced a precedence on that. Normally I'd be like, oh, that's just like 2 times the delta circle. Okay. Okay, the speed applied to both circles. Speed is 10. Circle radius is 32. Set target FPS to 60. Then we go into our loop drawing. So we say get mouse wheel move. If mouse wheel is not equal to 0, then we add that mouse wheel movement to the current FPS. Current FPS is less than 0, then we just set it to 0, and that's effectively infinity. Set target FPS to FPS. And then we get frame time returns the time it took to draw the last frame in seconds, usually called delta time. Uses the delta time to make the circle look like it's moving at a consistent speed regardless of FPS. So we multiply by 6 an arbitrary value in order to make the speed visually closer to the other circles. There we go. That's what I was saying. They did something. It's get frame time times 6 times speed. And this is 0.1f times speed. So this is 1/3 down the page. This is 2/3 down the page. That's what this was. Y positioning. And then here it's 1/10 of the speed, and then this one is 6 times the speed, but it's going to be 6 times get frame time. Get frame time is returning 2 milliseconds. So 6 times that would be 12. Oh, and you can see these are different speeds. They started out looking very similar, but the one above is actually going faster. Oh, because my target's off. That's why. Wonder if we do it here. They look very similar. I guess we'll see if there's any drift. But 0.2 times 6 would be 12. 0.10 times speed. Oops, messed that up. Yeah, up here. Where are we at? Here. So 0.12 times speed, this 0.1 times speed. So my guess is that the red one is going to be faster if we don't mess up and change this frame rate. So I'm going to let that go. Red should be faster, slightly. Okay. It might not be enough to add up to a single X value over the entire screen width, in which case these will both get set back to 0 and it won't have time to add. So that might be a thing that prevents it from separating. Yeah, it does look like red's beating it. Yep, I was right. Beats it slightly. Okay, it's a cool little demo there. Move ball with arrow keys. Oh, damn it. Okay, relib. So it just shows how you can like adjust position. Say, hey, it's being pressed down. We're gonna, so we can handle 2 keys at a time for diagonal. In fact, you can do 4 keys at a time, and it'll go nowhere. So I'll go 4. It doesn't do it anyway. Okay. Pretty basic one on that one. That just shows you this key down. So what am I looking for here? I'm just kind of like getting a little bit of experience at the library, but I do actually want to get around to doing the things I want to do here, which is draw a basic UI. Like a series of cells based on a buffer. So we'll just create a buffer here. It's going to be equal to some type of array. And we'll just say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16, 17, 18, 19, 20. Bam. Can I do it like this? Can I use auto with a... Okay, there we go. Surprised I can't do type inference on the array initialization. Alright. In fact, I'll pull this out here. We'll say int, or no, void draw buff. Let's be char star buff. give it a void star. And then here, buff C is equal to buff. Cast it to a char star. And we'll auto that. Bam. And then here, I hate it when the form error does that. For we need a length too here. Length, which is just gonna be what, int, or no, size t. Size of buff. This needs to be a register buff. And then we'll have a draw buff as well. And this will be a... What do I want to do with this? We'll just do goals here. We'll say buff char star. Sorry, char star buff. I don't think I have to initialize it to be null. We can just do that. And then length. We'll call it buff length. This will just be a size t. They'll both be 0 initialized, I believe. And then we'll just assign them here. Buff is equal to buff. Wait a minute, that doesn't work. Yeah, we'll do it like that. Okay. So we're just using this global memory here to register these things. And then over here, we will draw it. Draw buff. Buff. Oops. Okay. Draw buff. We'll take it as a char star, so we don't have to do that. Oh, it's not defined yet. Well, we'll just pull this up to the top. Here, bam. Drawing the buff, we're gonna say for auto I is equal to 0. Can I say size t of I is equal to 0? I is less than what? The len. Okay. So we need to draw a little square of some sort. Relib dot. Draw a rectangle. Okay, let's do that. Draw rectangle. So you give it X, Y, width, height, and color. So X, Y, width, we'll say 30, height 30, color, what is this going to be, dark gray, is light gray, dark gray, we'll do light gray. Oops. And it's going to be I times, so this will be const we'll just say size is equal to 30. Const auto. And then can I put a Z on this one? No. Is there a size T literal in C? What about Z, like in 30Z? Has assigned integer type corresponding to size T. So I did the Z here. That just gave me a const long. So Z is assigned size T basically. ZU. Okay. Ah, damn it. Well, let's go back over here, I guess. Jump over to VM viz. Well, let's see if it makes. Did AI just lie to me? It did. Okay. Well. Okay, let's ask Gemini. It tends to have better results here. basically I don't want to put the type on the left hand side. I want it to be inferred from the expression on the right hand side. I'm trying to figure out if C is capable of doing that. GNU dialog of C23, which relaxes the strict standard check for a specific literal token. Yeah, so basically GCC would allow me to do this. So let's just use GCC. And then take out this thing. I don't need that anymore. Make. It doesn't like it either. Does it want it to be ZU? I'll try both. Okay, it doesn't like that. Let's go back to Clang. C23 would do standards GNU 23. Glang. Clang. Yeah. Well, if we went over here to here instead of auto, just say like, and I don't even want the cons. Let's just do like size T, like that. Still doesn't like that. C23 literals. It's funny, both Gemini and ChatGPT both think that C23 has size T literals. But it's a C++ 23. And it's for signed size T. Because Z already exists. Okay. I'll just do the explicit types. Okay. Alright, make and build UI. Hey, I got them all at 0. That's not what I wanted. Okay, so we're going to draw a rectangle And then we need to increment I. So this will be I times the size plus 5. And we'll just say offset here. And we'll say size t, offset is equal to size time plus 5. Position's gonna be at like, we'll do an offset here. Width is gonna be size, height is gonna be size. And then we want to mod this. We'll say y position is equal to, do auto on this too. Okay, this would be y pause. It's gonna be offset mod width elements. $16. Sounds about right. 16 bytes. So that's going to be its y. Wait a minute, no, that's its x position. Yeah. And its y position. It's not offset, it's I. Okay, let's try that. Hey, look at that. Looks like pretty cool. I did want to have an additional offset initially. So the initial offset is just going to be a plus offset here on both of these. There you go. I would like to be able to get the resizing working. Clearly it's kind of working, because I can resize it kind of. Every time I try to do that, well, that works. Kinda. Alright, resize window. So set dimensions. Yeah, we can say set window size. Get window position XY on monitor, scale DPI. Let's see if AI can tell me what method to use here. With raylib on hyperland, how do I enable window resizing? Through the native resizing. Tile window resizing. There's just a set config flag window resizable. Okay. Set window min size, set window max size. What else do they do? That's it. Okay. If you go back over here, go into here, search for that. Set to allow window resizable window. Okay. And that's going to be in, oops, some other call. Set config flags. Okay. So go back over here. Down here, create window. Like that. Make. Hey, look at that. It's kind of like a flicker. See how it like moves around as you resize? It's kind of weird. Oops. Yeah. I guess it's not that big of a deal. See if you run it again. Yeah. So it launches tiled, which is nice. Okay. So next thing I want to do is draw the actual byte inside of the element. So what do you want to do here? Draw buffer, draw a rectangle, and then it's going to draw some text. And we're just going to draw it the same position. So we'll just say xpos. We can delete this test as well. I don't need that anymore. So it's going to be xpos, white pause. And then this will be, so we have light gray, dark gray, and mid gray. Dark gray. Okay, and the text we gotta create from byte string, or from a specific byte. So let's read the byte. It's gonna be a read from our buff sub our element, which is I, and that should be a single char, and we want to format that. So I think I want to do man s printf, man s printf. The V is for VA list. The hell is VA list? SN printf, and you probably want SN printf. So man SN printf, and then the VA list. What does that thing do? VA list. Okay, something with variadic arguments. We are going to instead do a sn printf of we want our text to be a char array 2, 3. And we could do a simple switch for this, to be honest, but we can use sprintf, it's fine. Now in here, we give it the char string, the size 2, and then the format string. So this is the string we're going to write it into, which is text. The format string is going to be 0xb. No, what am I doing? Percent x. I think it's like that. Oops. And then this is going to be char here. I think that's right. I can use clang REPL here. Clang REPL include, and then I'll do basically, yeah, let's do char text is that, and then we'll say char byte is equal to what? We'll do like 88, or do 0x4f, and then we'll do this. Oh, because char should be byte. Yeah, my bad. There we go. I need to include that standard IO footage. And font size on this would be what? Size -3, 4. And if I just printf out, or I can say puts text, it gives me back 4. It's not what I expected. I expected it to be 4f. Oh, because it's limited to 2 here, I need to do 3. There we go. Okay. So this max length should be size of text. There we go. Okay. Let's go ahead and make, rerun. Oh, it's so ugly. It's so ugly. I think we can say 0 on this formatting to get the full byte, maybe. No. 2. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we had a weird offset here. 1, 2, 3, 4, 5. That's weird. 1, 2, 3, 4. Yeah, well, 1 byte extra here. That's weird. Let's figure out why that's doing it. So we start at byte 0. I is not being mutated. Except for in the post loop increment. I is just being read. So that means the 0th byte is 0? That doesn't make sense. That means my pointer's messed up probably. Register buff. No, that looks right. When I register my buff, I just assign it. Yeah, looks right. This is weird. Let's do a printf here. We'll just say byte %d is equal to %x, and we'll do what? I in our byte. Oh, I need to do the new line too. L? Yeah, okay. Alright. Oh, and it keeps on going to 80. I guess 16, 17, 18, 19, 20. It says 21 times 4. Or 20 times 4 would be 80. My initialize this slide went to 20, right? Yeah, literal 20 value. Oh, but we're going by index, so it's a 20th index. Yeah, so that's going to be 21 different values. 21 different values would require times 4 would be 84. Yeah, we got up to 83. That's expected. Oh, I need to kill this because it's doing every loop. Why is that? I would not have expected it to be that way. Oh, I get it. It's because it's a 0 byte. Here. 0 value, least significant. So byte 4 is where we start storing, and that's where you get the 1. Okay. Alright, let's delete this printf, so that makes a lot more sense. And if I go back here and run it, so that makes sense. Yeah, everything makes sense. I don't know why I misunderstood that. Okay, so I'd like to get the drawing a little bit better. The problem with this font is that it's variable width. I want a monospaced font. Mono. Okay, let's go in here. It has draw text EX. And now we say font. Text. Vector 2. Vector 2 of position, which would be XY, font size, spacing, color. Origin, rotation. I guess mainly rotation. Draw text code points. Draw one character code point. Draw multiple character code point. What is this code point? This is just the header file. This is their cheat sheet. It's just the header file. They just kind of carved up the header file and made it a cheat sheet. I like it. I like the cut of their jib here. All right, examples, text. I want a monospace font. Maybe if I uppercase it and use a default font, it'll get like more consistent width because they're uppercase characters, hopefully. Let's try it. Okay. I think we do a X here for uppercase. Nah, it doesn't really work. The thing I want to do is I want to center everything. So you have to compute it relative to... So you have to compute the width of it, and then you have to get the viewport size, cut that in half, get the width of your thing, cut it in half, and then take the width of the thing minus the width of your thing, and that should be the starting position for you to start drawing. Oh, let's try getting that. Alright, let's make the size a little bit bigger. Let's go to 40. Our size is going to be plus 10 to the offset. Width of the elements, yeah, it should be 16. Every 8 elements, though, I want to give it an extra boost. Like twice the size. Like every 4 elements should get a half boost. Every something like that. So X position, I want to say auto boost, X boost is equal to this would be I mod what is this, width elements is equal to let's just do this as 0 here, And then we just say switch imod with elements. And then here we'll have case 8. Then x boost is going to be equal to 2 times let's do size t margin. It's equal to 10. We'll just say margin here. And if it is, say break after that. And then case is gonna be 4 or 12. And then we assign to be half margin. Oh, and I need to actually add it. So it'll be x position plus x boost. There we go. So it kind of chunks them together in little nibbles. You can see here they're bleeding together. So this is going to be different. So should change this to be an if. Auto, we'll call this what, like X pause? No. I pause. There we go. And I'll leave that there, it's fine. I don't really give a crap about that. I pause. Sorry, if I pause is less than, sorry, is greater than, hold on, how do I want to do this? We'll say less than, so 0, 1, 2, and 3. 0, 1, 2, and 3. So we less than 4. Then we do nothing. Else if I pause is less than 8. Then actually, I think I want to reverse this. We'll do greater than or equal to 4. Then we'll do that. Bam. And equal to 8. And then we're going to do it again. This will just be my margin. And then greater than or equal to 12. Sorry. We'll do another half here. Okay, I think that'll work. Does that look better? Well, we can figure this out by jacking up the margin. Or we can do it here, plus 50 or whatever. Plus 50. plus 50. So it doesn't really work. Oh, because I'm not doing the right thing. I need to do plus equals. There we go. Hey, there we go. Everything looks good there. Okay. So now we can take away the 50. And hopefully that's like sufficient to space things out a little bit. Yeah. I'm not a huge fan of that. Let's try margin 20. Okay. Maybe 15. Okay, let's get the font a little bit smaller now. Font size is size -4. That's what I computed it as. Let's do font size here. Size or auto font size equal to, oops. Size -10 or times. Can we do divided by 4 times 3? Like that? Keep it in integer math. Sorry. Size like that. Okay, and we need to center it a little bit. So in here, we draw a rectangle, and then we generate our text, and then we draw our text. But I need to do that thing I was doing before with measure text. Measure text, which is going to be text and font size. So we have the XY position of, we need to do some math here. Box center X pos. It's going to be X pos plus the size divided by 2, and then same thing for Y pos. Okay. Auto. Alright, so now we have the center of the box. And now we need to know the, so we measure our text, text width, auto text X pos is going to be equal to the box center X pos minus the text width divided by 2. And then the text Y, and then this will be the font size divided by 2. And then this becomes text X pause and text Y pause. Yeah, so it's mostly centered. We could do a little bit better job, I think, and then I bet you it's gonna have some jitter when I move it around. Not a lot. All right, let's center the whole container then. Do I want to do that? Or do I want to wind it up here for the night? How long I've been streaming for? Might have been about 2 hours here. Would be nice to get it centered here. What I'm thinking is that like doing this math to get the positions is fine, but like having like there's a reason why the browser's DOM uses like containers and offsets from the container positions. It's just a lot easier to think about, I think. Oh, look at this one, 0C and 0D. They only got 1 pixel. So we need to bring this size down even further. So the font size needs to be maybe about half. We'll say times 2 maybe. That's not big enough. Say divided by 8 times 5. Oh, that's so ugly. Maybe 6. Yeah. I need a better font than this. I need the boxes to be slightly bigger, and if you look here, I think it's giving it 1 pixel to the left and not to the right. I think it's a little bit too high up too. So maybe let's make this a little bit taller. Instead of 40, maybe go to 50. Okay. There's some chunky boys there. And then we can start scaling back the size of the text, I think. So we can go to 5 now, or let's go to 4. Nope, too small. And 5. 5's fine. I like that. Okay, and then I want to add a little bit to the height. So that'll be text here. Plus 4 maybe? Nope, too big. 2? Yeah, I think it was just 1 pixel to be honest. Off by 1. There we go. Alright, and then let's center the whole thing. So that'll be up here where we compute X position here. We need to add on because right now we're doing it from the upper left. So this plus offset, I'm going to delete that, which will throw it all the way flush with the upper left. And then we're going to say plus here. X start. Say X start plus here Y start. We can say auto Y start is equal to offset. X start will be based on the width though. X start will be get window position. We'll just do that here. Auto W pause is going to be equal to that. This will be W pause dot X. And then, no, not window position, get window size. Because window pause would be the actual window position on the monitor. Okay, get screen width. I don't know the difference between a window and a screen, but this is just an integer, so we can put it in line here. Screen width divided by 2, and then we're gonna have to compute the size. Auto size of the whole layout is equal to, say, X, layout width. So that's going to be the, we can do all this outside of the loop. It's going to be len times we'll do 1 for now just to get it happy with the static analyzer. So it's going to be a length of elements times the size of those elements. Size plus we're going to have these little boosts. So we're going to have one margin here, boost, and then one split up between the two. So that's 2 times margin. I think that's it, right? Oh, and then the margin. Yeah. I think I need to do it like this. And I think I only need one margin. So you had the length is a number of elements, but the last margin you don't need to add onto this calculation. So it's going to be the length times the size plus the margin, but then we need to subtract the margin off. And then we need to add 2 margins on. So I'm just going to add 1 margin. That's a net 1 margin. And that's going to be the layout width. So then I get this screen width, I divide that by 2 to get the midpoint. And then I'm going to subtract off the layout width divided by 2. And that's going to be the X start. And the Y start is just the offset. Is it an offset or is it a margin? Well, we'll just do it as size for now. In offset, we're already calculating as size plus margin, so we can just do that here. Offset. Reduce that calculation there. Okay, let's go ahead and run it. Okay, something messed up. Oh, it's way over to the left. So how about we just say auto layout width is equal to 0. So that does put it center, which is nice. So that means our layout width is crazy. Okay. So layout width is supposed to represent the whole width, and then we divide it by 2, and then we subtract that to shift it to the left. So there's going to be a length times the offset plus a margin. That seems correct to me. But clearly not. Maybe if we bring this back here and say like 300. That's probably excessive. Not really. If I do 0, so that is like literally, it shows just a fraction of the last nibble. If I do 100 here, it shows, so it basically 50. So it's showing 50. Yeah, that's about right. So I need to log this out, say console log, printf. It's like, what the hell? Layout width. Yeah, that's huge, bro. 5,000. So length is going to be like what, 16? Oh, it's not length. It's length mod. Actually, it's just width elements times the offset. Yeah, okay. That's why. All right. There we go. It is centered. Look at that. Okay, well, we got something accomplished tonight. We were able to draw a buffer out of arbitrary size too. If we hit Control C here, we can like go back over here and we can go add elements to our buffer. Say 21, 22, 23, 24, 25. Look at that. Okay. Starting to get a hang of some of this stuff. What'd be nice if I could like zoom in and out, but I don't know if the freaking pixel rendering on this pixel font is gonna like play nice with zooming. I can't do zooming like yeah, I can't do zooming. Well, first of all, I don't like this font because it's hard to read. Like, especially like 0D, that's like too close to 00. It just, the characters are not super clear when I just look at it. Um, Whereas, like, if I had a real font, it would be much clearer. Um, the second thing I'm kind of curious about is like anti-aliasing. So if I do the zoom thing, you're gonna have float values for positions. If I go back over here and look at the positions here, pause X here on draw text. Oh, no, I don't want to do that. Let's do draw rectangle. These are integer values. So you have a rectangle at X position, Y position with width and height, which are probably also integers. So yeah, it's not really allowing for floats. A vector 2 is also integers. Oh no, vector 2 is floats. Okay. So if we do a draw rectangle V, maybe we get some anti-aliasing going there. Or draw rectangle rect. Okay. Position and size? Should be width and height. Too. I like this rectangle better. X, Y, width, height. So let's do draw rectangle rec. And see if we get some floaty anti-aliasing going. Draw rectangle rec. And I'm gonna paste this into a rectangle. Can I create a rectangle here in line, like you would do in Go? No, probably not. So it's gonna be auto rec is going to be equal to rectangle, like this. Can I do that? That's very Go-ish. Rec. Yeah, I think you need to do dot x is equal to that. Dot y. And then I think you have to have the type over here like that. Okay, so I don't need these because it implies that through position, which I'm happy to delete. Why did that not format? Okay, there we go. So what I'm going to do here, oops. So I think what I'm going to do is the width, I'm going to add 0.5 to. I can add a half step to the width and height. 0.5. Just to see if I can get some anti-aliasing going. Okay, it doesn't like that. Did I mess something up here? Yeah, I didn't do a plus sign. That would help. I can't see that 0.5, to be honest. do 0.25 here. Zero 0.5. Seven five. Yeah, it's not doing any anti-aliasing there. It's probably rounding them, even though they come in as floats. This might be like a cool shadow effect, but you'd have to I'm just playing around here. Oh, interesting. So this is dark gray. This is light gray. Oh, but the dark gray is the background. Let's do black. Yeah, you can kind of see it. Let's do one, actually 2.5. Yeah, look at that. Some old school graphics there. So I think this thing's doing anti-aliasing. I would venture a guess. Can't really prove that. Guess I can take a screenshot here, maybe zoom in. How do I zoom in? Does it save that thing somewhere? Pictures today? Oops. Can I zoom in here? Well, it's anti-aliasing the whole freaking image. That's a bummer. I can GIMP it. That might be a better way of doing it. Open with GIMP. Good old GIMP. Okay. Yeah, it's a little bit better. Yeah, you can see it's not doing any anti-aliasing. But that might be because my width and height are fractions as well. Let's try this again and force it to be fractional. So x position, y position, width will be size, which is integer. Same thing with this. And we'll pull it down a little bit extra. Okay. So print screen that here. open with GIMP. And then if you zoom in here, you can see none of these things are fractional. None of them doing anti-aliasing. So if we go over here, what's interesting is it was clearly rounded differently though. I'm just gonna draw some rectangles over here just for testing, and we'll grab this thing here, call it rec3, and we'll literally position it at position 0, 0. Its width is going to be 10.25. Height will be 5. I'll just do this 5. This will be rec 4. This will be 5. Y will be 0. Width will be 10 points. Well, we'll do 10.0 here. 10.0. 10.25. 4. Oops. 4. 5. Oops. God damn it. Okay. 5 here. 10 here. And then this will be 10.5. So we have rec 3, 10. 10.25, 10.5. And then a final one, rec 6. Will be, I have to fix this thing too, this one. So 3, 4, 5, 6. This one will be 7, 5. Oops. 7, 5. And I won't bother with the last one. Okay, let's do our make. What? Oh, they didn't do the offsets on these. I did them, but not for this one here. So 0, 5, 10, and 15. Okay. There we go. And I don't... Let's get them off here a little bit. Like, do like... Maybe like 100. And then Y will do 100 as well. So get it off the boundary there so it doesn't get mixed up with the other stuff. Yeah, it looks like it's all just like one thing, to be honest. And I think I need to add 1 pixel here, so I'll make the height just be 4. That gives 1 pixel boundary. And then the last one here, we'll do a rec 7. 20. And then this will be, what, 11? Oops, sorry, 11. And that'll be rec 7. Weird. Well, we're gonna find out here what's going on. Let's go ahead and full screen. I don't even think I need a full screen, right? Should be the same. Yeah, I'll just print screen. Open that up with GIMP. This one here, open with GIMP. I missed the chat. Hey, what's up? Sorry, Mr. Chat. Yeah, I just did hit on Sunday, and I was really sore today. But I measured my fasted glucose this morning. It was at 87, which is pretty sweet. Alright, let's go in here and zoom in here. Oh no, not there. Isn't that bizarre? It just does a full flush. It doesn't even space these things off. Maybe I'm doing something wrong here. I think I am. Okay. Let's do alternating white. White. Oh. Does that come through? Oh, my positioning is on the X instead of the Y. That's why. So these values just need to be reversed here. Let me see if I can do it with Vim. Column selection. Looks like that worked. Except it messed up everything else. Alright. That one's fine. This one's gonna be 105. 110. 115. 120. And then these will just all be zeros. Alright. Alright, so our X's are all the same, our Y's then differ, and then our width. Okay. Let's do our make. Okay. Looks like we got some things there, that's good. Alright. Let's open with GIMP. Zoom in here. Yeah, you can see it jumped up right at the point of 7.5. It rounded it up. So 0.5 and below gets rounded down. And then anything above 0.5 probably gets rounded up. And this should be 1 pixel, which is about the size of the distance between these. So, yep. That is what it's doing. It's not doing anti-aliasing. So let's see if we can trick it into doing anti-aliasing. Let's actually go to the cheat sheet, which is the header, and say alias, sound alias. Let's ask ChatGPT, can Raylib do anti-aliasing on float values in between pixels? Multi-sample anti-aliasing. Okay, well, let's try it. So that would be under, well, we'll just do it in the main, because we're probably going to throw it away anyways. What is this thing here? It says multi-sample anti-aliasing 4x. Alright, so if we do that, Does that give us any benefit on the anti-aliasing front? Let's see. It doesn't look like it. So that's 24 here. Oh, look at that. It did do anti-aliasing. Amazing. And look, we got anti-aliasing on here. Yeah. It's pretty cool. Alright, I'm going to go back over here. The X value, where is it? Down here. We'll call this thing, instead of rect, shadow rec. Shadow rec. And then this thing will just be rec. And oh, 2.5, yeah, let's do 2.5. Okay. Maybe a little bit more. Maybe like a 3. Yeah. That looks good. So we are getting anti-aliasing now. What did AI say about this? Raylo can enable hardware MSAA, which is a main way to smooth edges. This helps with diagonal lines, polygon edge, geometric shapes, but still does not give true subpixel rendering. Just samples multiple times per pixel and averages. We draw shapes or textures with transparency. Edges are naturally blended. Positions are always float internally, but rendering still resolves to pixels. Smoothness comes from MSAA. The geometry edges will be smooth. What's interesting is I think if I draw a circle here, we can really see the anti-aliasing kicking in. So let's do that. Let's go down here, disable the anti-aliasing, and I'm just going to draw. I'm actually going to pull these things out as diagnostics. Here I'll just say void draw bars, for lack of a better phrase. And then I'll have like a draw circle here. And I think this is just going to be draw circle. There's a draw circle V. We'll just say 100. 100. Radius is going to be what, like 50. And color can be white. And I'll do this up here on, actually I'll do it in the draw loop directly here. Draw a circle. Which means that we need to pull this draw loop down to here. Okay. So this should show the the lack of anti-aliasing. You can see just how jagged. It's pretty hard to see in the stream. Maybe yeah, let me take a screenshot here. And then open that with GIMP. But it's pretty clear, like, how jagged this drawing is. Like a stair stepping on the circle. Now if I go over here and I just enable the anti-aliasing, way smoother. I mean, it's still not perfect at a glance, but it's less obviously janky. See how smooth that anti-aliasing is? I think the artifacts you do see are optical because fitting a circle onto a grid, it's just gonna have some like nodes here that kind of stick out. But from far away, you can't really tell at all. Okay. So, sorry, foreground. Let's go ahead and delete that. Okay, what do I want to do here now? Let's maybe like pull some logic out here, out of this thing. So actually, I'm not going to do that right this moment. I think it's a little bit premature. So draw a basic UI with a window and boxes in a window display values from a memory buffer. Okay, I think we did that. If I go back here, I can do that. Yeah. Okay. It's a pretty nice little library. What I want to do now is zoom on the scroll wheel. So this is going to be fun. We can do this. I'm going to just set it as a global value because every time drop off gets called, it has to reference it. So we'll just set it up here as float, actually double. We'll do a float. We don't need the precision. Float zoom is equal to 1. And this is going to be jank. I know it's going to be jank. I know it. But basically, let's pin the start position. So I don't think we need to mess with the X, Y, and the X start and a Y start. But everything else needs to be scaled by the zoom. So size will be times zoom. That's the big one. That's going to factor into font size. Margin times zoom. Offset has size and margin together, so that's going to be fine. This is just a number of elements. This will be fine. Layout width will be dynamically calculated because offset and margin are affected. So that's all fine. Y start size fine. The boost, the margin's gonna be divided by 2. That's fine. I think everything else is fine. So if I write that out and I run this, everything's normal. If I have it, let's go to zoom is equal to 0.5. Or let's do 2. Then we go 2x it. So that definitely zoomed it in. And if I have it, wonder if having will actually work. 0.5. Yeah, looks like it did. I mean, there's a little bit of issue with the font, obviously. And I think that's just I need to get a better font. Because this is like a pixel font that doesn't really render very well in some resolutions. But that should be pretty easy to source a monospace font from the open source, like the Nerd font, or I forget what font I use. Let's see. Style? Font? I don't even know which one I use. But I think the JetBrains stuff is free. It would have to be a free font. I'm not gonna worry about that right now. Let's go back to setting zoom to 1 here. And then let's say scroll. I saw an example with the scroll wheel up here. Core, this guy, he had a scroll wheel here. Get mouse wheel move. And then if it's not equal to 0, you modify it. Okay. And you do that within the draw loop. So here we're going to say update zoom. And then we're going to draw buff. So here, void update zoom. And that's going to auto. And then value, which is called value, get mouse wheel move. If value is not equal to 0, this will be zoom val, and then that we don't have to worry about. And then we can do this like that. Boom, boom, boom. All right. All right, that's zooming in. It does work, but as soon as you get below 0, I think it just subtracts it to 0. I don't think we get fractional. So I don't think multiplying it, or adding I should say, is gonna work. Let's do print, sorry, printf out, say zval %d or f, new line, oops, sorry, new line, val. Actually, I'm gonna do it in here. So I actually only want to do it when it's updated. All right. Yeah, it's either 1 or -1. Okay. So what we'll say is we're going to times equal it No. If val, if val is less than 0, then we'll do something else. We're going to do something else. So this is going to be zoom times equals, we'll say 1.1, and then this is going to be times equals to 0.9 maybe. All right. Hey, look at that. Oh my god, that's a really good job. I mean, at some point I think we need to stop drawing the, well, we do stop drawing it, the text is glitchy. I think we stopped drawing the text right about here. I don't know what value that is, but we can experiment with it. So here, what do we want to say here? All this text stuff here. If zoom is less than 0.2, then we're just going to continue. And not draw any of the text. So maybe we go until about here. Seems like maybe 0.5. Or 4 maybe. This is gonna be cool. I'm excited about this. I'm excited I got Zoom to work so easily. I guess maybe the next thing would be to like load a font in. Show me code for Raylib using custom font for text. Font is, let's do setup font. No, sorry, style font. I hate it when it does that. JetBrains mono, JetBrains motto, nerd font mono. Actually, let me go under local, rip grab for JetBrains mono. What's NL? I don't even know what NL is. Let me go under config. Alright. What is all this crap? GIMP? I didn't even know GIMP had a config directory. Font configs font? Okay. So what is my font? Well, it's SKI. How do I tell my current font usage on Omarchi? Search online. Omarchi font list, okay. Let's try that. Font path goes in where? No, can't be that hard. Let's go up here to fonts, text. Yeah, like here, sprite fonts. Oh, those are like PNGs. This is TTF, okay. It looks like it has to be relative. Alright, well, I'm gonna go by their code here. Examples, which grabs a font here. I'm pretty sure I could do this globally, right? I have to do this multiple times. Is that the actual location? Let's see. Stat that. It is. Okay. What is this font size 96? Alright, what do we do with the font? Font. Let's see here. Generate MIP map levels using trilinear filtering. Note on 2D drawing it won't be noticeable. It looks like filter bilinear. Okay. And then we say base size is the font size. Font position, font text. Can I just give it to draw text EX font? Message. Alright, let's do that. And up here, we can just say, hey, font. And down here, we say draw text EX. Font text position, font size, spacing, color. Okay, let's zoom in here. So this is going to be font text, the vector 2 of that, which should be text position is going to be equal to the vector, sorry, this needs to be a vector 2, and then we do brace initialization, and here you can just pull these things down here, do that, like that. Text position, that now becomes text pause. Font size is still there. Okay, everything else, oh, we need spacing. 1. Result of integer division used in a floating point context. So we take text width, which is an int. Loss of precision, that's fine. We'll just do it like this. And say, hey, you're float. Right? Vector 2, box center x pause is a size t, which is the integer type. Text width. Okay, I don't want to deal with that warning, but I can't get rid of it, so I'll just deal with it. Alright. Did not use my text. Did it? Yeah, it did. Because it, no, it's the same one. Okay. Okay, didn't like the font. Why is that? Just hoping to get away with doing the easy thing. So I loaded it up, the file definitely exists, and then I used it, but there's all this other junk in here. Let's see. So they do the font path, blah blah blah. So I gotta do load code points on sample text. Text containing characters you want to support, important for glyph extraction. Why do I have to load code points? Load code points. They don't do that in here. I'm gonna go by their example here. Okay, so where are we at? Where do we do the load? Here. That's where we do a draw. You go up here, load font EX. We do need a font size. And we did do a load initially. So this is unloading and reloading it. Load a drop TT file dynamically at current font size. Let's see here. Set texture filter. Texture filter point. 0, 1, 2. So we go here, we can say 0, 1, 2. I can't tell the difference at all. Well, we would do 0 here. Yeah, it's like it's not, didn't find the font. Load font from file with extended parameters. Use null for code points and 0 for code point count to load the default character set. Font size is provided in pixel height. I guess I could pass null there instead. Do code points null. Not that it matters. And then are we sure this is a file? Pretty sure it is. Let's grab this again just to make sure. Stat. If I had something else, give me that. Yeah. Okay. And then font, it's written to there, and it's read from there, but it's not using it. Font size here. This is load file data. What the hell? We are using unload font here. I really wish these examples are like a little bit simpler. I understand they want to like kind of demonstrate all of these features, but like I just don't want to read all the freaking code for a simple example. Okay. There's font default and font SDF. Font default signed distance field, I guess, SDF. Font default. That's just like the default font that ships with the. Hold space to use SDF font version. Oops, I need to click on it first. So it just zero initializes it. Here they do a load bunch of stuff. Here they do this stuff. Load font data. Gen image font atlas. Unload image atlas. Load texture from image. So this is doing a lot of like rendering of images and stuff, which is why it looks pixelated up there. This one, they do something similar here. Oh, but they pass different parameters. They pass font default instead of font SDF. Alright, this is a very advanced version of doing that. This one looks nice. So they load their font. Set texture filter to bilinear. Maybe I do need to do this at some point. Let's do that. Right after we load, just set that font texture. Okay. Oh, Nodo Sans TC regular TF. Why do we have to load it again? Does it get unloaded? Unload close window. But why would you need to do it in the one? Oh, because it gets unloaded every time? This is using load font and it just gives it one argument. And I'm using load font EX. Maybe I should just use a simpler one instead of complicating it here. And then, is there anything else that they do? They do code point ranges. Add code point range. Oh, you can do initialization like that. I did not know that. That is helpful. It's kind of like in Go. Okay, well, let's give it a shot here. See if that fixed anything. Nope. File loaded successfully. GPU is not ready to load data. Try to load before init window. failed to load font texture using default font. Core dumped. Okay, maybe I need to do this after the window initialization. Before the drawing. Okay, we got our font now. It is very pixelated. Like, I would be expecting it to redraw it better. Okay. I think we can go down further than this here. Let's do maybe 0.3. Two maybe? Or 4, sorry. Maybe 5 was right. Maybe a 4, 5? Yeah. That was interesting. It was like drawing the back faces and not the front faces for a hot second there. Oh, caught it once there. Okay. It doesn't look very crisp, so let's do maybe comment this out, this second line here. Set texture filter. I want to re-render the font. Maybe if we do the AX one now. Say, hey, load font EX. And then this had a bunch of other stuff here, which was font size null 0. So maybe we do like 256 null 0. Yeah, that gives us better rendering at this size. I think what I need to do is re-render it every time I draw a frame, unfortunately. So let's go in here, do this up here. So every time we have a new font size, we can then load the font, giving it font size. And we'll just make this a font local here. And then we delete the global. So now when you zoom in, it's nice and crisp. Zoom out, retains that quality, and then at a certain resolution, just stops drawing it. Since they're monospace, you would think it would get a better calculation for let's look at cheat sheet for font. Font. our textures. I want stuff that returns fonts. There we go. So load font EX takes in the font size. Oh, it might be leaking memory here. Or file descriptors. You have to unload it. It's a good call, good call. So we'll say unload font. We'll do that after, oops, do that after our loop down here. One thing that we could do is like load fonts for all the sizes into like an array and do that up front. That would prevent us from opening and closing, opening, reading it in, closing it, doing all the work, every draw loop. That's like an optimization. Oh, look at that. What is going on there? That's wrong. All I did was unload font at the end here, which I thought was the correct thing to do. Apparently not. Isn't that bizarre? Okay. Alrighty. Well, made some progress on this. We got the buffers displaying. See, now this, I'm not happy with that. The offset there on the 11. I feel like because it's monospace now, I should have a constant for all of these instead of calculating based on the width. What is this thing complaining about? Oh, it's this old buffer. Okay. So here we measure text. This text based on the font size. Oh, maybe we need to pass in the font here. Measure text EX. Yeah, that's what we need. Pass in the font, the text, font size, and spacing. Text, font size, and spacing was 0. There we go. That's probably why it's messed up. And we get back a vector 2 now instead of an int. But if I say .x here, but really what I should be doing is saying text size, and here now we can say text size dot x divided by 2 text size dot y divided by 2. And then I might be able to eliminate that +1. See how that looks. Looks pretty good. Yeah. If you zoom out, yeah, I think the +1's still appropriate. Zoom out, yeah. Might even need a +2. But yeah, I'm pretty happy with this. We got our monospace font loaded. It's not super optimal the way it's loading it, and it might actually exhaust file descriptors at some point because I wasn't able to unload it. So some work needs to be done there, but I think I had a good spot to quit here for the night. We're displaying an arbitrary buffer of arbitrary size. We can zoom in and out. We show the actual values in each cell. Yeah, I think this is a good start to using ArrayLib, and I just wanted to explore using ArrayLib. Wasn't really looking to do much more than that with this session. So if we go back to our Excalidraw that we started at today, we basically are doing this part here. Like all the other fun, interesting stuff, we're not even touching yet because I wanted to get a good handle for like how I would approach actually displaying this stuff. It is pitch dark in here. So yeah, I think I got a good handle of using ArrayLib to display this stuff. I think it's a pretty sweet library. Like enabling anti-aliasing was like a single bit flip. A single little flag that I had to set. Pulling in like a font that I like was really easy. So yeah, I am pretty happy with what I did today. But obviously like the meat of the program is actually tracing, copying memory from the trace process, doing diffs, reading in the maps. And the other thing that is pretty obvious here is that this is only showing a very small amount of memory. Realistically, I feel like for this to actually like function at scale, it needs to be able to, like, if I had a let's do a array, maybe like one bit shift over 20. So this is gonna be huge. That is 1 meg basically. Yeah, you can see it. It's not performing very well. It's doing it though. But you can see obviously like it's not gonna be able to perform very well with huge buffers like that. Maybe we do like 8. Sorry, 8, not 80. Okay, so it did well with that. Another thing would be nice to actually show the addresses on the left hand side. I imagine 10 should not be too hard. Yeah. The other thing we need to do is set positioning to be able to scroll up and down, have like a sense of scroll. Which is going to be odd because zoom is scroll, so I might have to do a modifier like a control. Or what do people normally do? What do people normally do? The other thing is like this shows basically 2 bytes. 4 bytes would be a four bytes would be a 32-bit word, and then 64 would be a single cache line, and it would also be a sorry, I don't know why I was saying that. 8 bytes here is a 64-bit value. So it fits in 2 32-bit values. So you can fit in 4 32-bit values in this view, or you can do 2 64-bit values, or 128-bit value, like a complex number that was properly aligned would fit into one row. But I guess it's only 16 bytes. And if I wanted to show a full cache line, it would be, how many of those? It would be 16, 32, 6. It would be 4. So 4 of these is one cache line on AMD 64. That's one way to look at it. I could also just like display more bytes. So if I went up here to, where's that constant here? 16. If I just did a full cache line, so that's the way that would look. The spacing got left behind. So let's fix up that. How do I want to do that? I don't like this, so let's do something different. Let's say I divide it by width elements. So you can say like I divided by, these should be constants. So I divide by 4. I think we can pull these out and just do 4 and 8. So here would be I divided by 4 times margin divided by 2. I divided by 8 times margin divided by 2. Something like that. I think that might work. Should test it out. Nope. Definitely did not work. Let's get to work back on. Oh, it's because that's another reason why I messed up 64 here. But yeah, let's get it working on 16 first, and then we'll expand from there. It does kind of do it, but now we have to remove it. Yeah, so we have to mod it out. It shouldn't be I then, it should be the I position. There we go. Oops. Must have typoed that somehow. Don't even know how I would have done that. Okay, so that works there. And now we can say 64 up here. There we go. So each one of these rows is a single cache line. The thing that I don't like about this is that, like if I was to have this to where you can select a range of bytes that were like instructions and you want to disassemble them, it would make the UI kind of like crappy. I think. I don't know. We'll see. It's definitely easier to like show a lot of data. When it's like that. So this is like how much? That's 1K. So maybe we do like 15 here. So now we're starting to chug a little bit. Yeah. And that's, I guess another thing is that I'm not parallelizing this at all right now. It's just all single threaded, drawing squares. I'm wondering how much of this I can parallelize. Like if I look at B top here, it's like the draw UI is definitely taking up the most CPU. Let's get it chugging along here. We'll do 20, which is 1 meg. And you can see like it's blasting a single core here. Culling is another strategy, like just doing the math to see like, is this thing even going to be shown? And if it's not, just don't even draw it. But yeah, you can say like it gets put on a core and then that core blows up. You see, bam. So it's not spreading the load out amongst a bunch of different cores. What's amazing is like what I'm seeing here is that it's actually moving around to different cores. So that means the kernel must be doing context switching to send it around. I wonder if I can pin it to a single core. Let's see. Huh. So you say set schedule affinity. Okay, we'll grab these. And then Vim, sorry, can I have foreground? Yeah. Let's go back up here. Oops. Okay. Paste that stuff in. And then delete that and grab this. And then go down here. Do that up here. And then maybe this good news source needs to go, oops, above here. There we go. There we go. And then let's bring up B-top. Yeah, you can see it's pinned to that core now. It's blowing it away. That's pretty cool. And then if I kill this and I move this guy to 4 maybe? Let's see if he moves to 4. Yep. Blowing up 4 now. And then if we say, hey, I want to do 4, 5, and 6, but keep me in that range. Oops. Sorry. 4, 5, and 6. There we go. So he landed on 5. And now he's getting moved on to 4 maybe? No, he just stuck on 5. I thought maybe he'd bounce around a little bit. But if I kill him and just rerun him, he might go into a different core. No, he got to 5 on that one too. Let's try it again. I want to see if he can get onto a different core. No, Linux likes putting them on 5. What if I run 2 of them? Let's go over here, jump over to VM Viz, build draw UI. Okay, that one went on to 4. And if I kill this, wait a minute, he went back to 5? How is that even possible? Okay, so this one here is on 5, clearly. If I run up here, he's on 4. This one up here is on 4. Clearly, I just started it, it's showing there. If I go down here and kill this one, it moves the one from 4 to 5. It's like 5 is like some special value in that set. I've never seen that before. Must be something to do with this CPU set stuff. Is that like, is there a man page for that? Man CPU set? A schedule affinity? Sketched set affinity. Yeah. On a multiprocessor system, setting the CPU affinity mask can be used to obtain performance benefits. For example, by dedicating one CPU to a particular thread and setting the affinity mask of all the threads to exclude that CPU. It's possible to ensure maximum execution speed for that thread. Restricting a thread to run on a single CPU also avoids the performance costs caused by the cache invalidation that occurs when a thread ceases to execute on one CPU. and then recommences execution on a different CPU. Oh, I was misusing that. Oh no, it said size of here. Okay. And PID 0 is just current PID. So that's interesting that you can go through and set the scheduler affinity for everything else on the system except for your process. That's interesting. Well, that was fun. I've never played around with that before. Let's go and delete it. I don't think it's really necessary. Yeah, it's pretty much the same thing as this, right? Let me ask it. In Linux, is there a way to tell the kernel put my, I don't care what core I run on, but just don't move me around to other cores. Let me cook on the core you put me on for a long time. Okay, so you would have to like say, okay, I'm gonna add all the cores to the set my affinity, then wait for us to get scheduled somewhere, and then get that CPU, and then create a new set or zero out the set and set only that one CPU to my affinity. That makes sense. I guess you wouldn't even have to do this first part. Yeah, just do the second part. Okay, let's go ahead and reset this canvas. Actually, before I do that, I was trying to log off here. But I kind of got distracted. So yeah, before I log off, everything that I've done was on this side of the thing. And I think I'm going to spend a good amount of time just like developing all the display stuff, because this is going to be a very visual program. So I want to drive it from the visual side And that includes getting all the Zoom UI like working really well, getting it working well with large data sets, make sure it's performant, doing any type of like culling and parallelizing of rendering. All of that is to the right hand side of like the state. I might even start specifying the state as well that I read from to update the UI. So that all will be work that I probably do in the next week. And then the fun stuff really is tracing a process and doing all this memory copying and stuff like that. But it's probably realistically less work. So I want to start from like the UI because it's like a UI driven program, and then back my way into wiring up all of the tracing stuff, if that makes sense. And then I might bounce back and forth at that point. But I think this is a good place to start is on this side, the user experience side. So I'll be doing that this week. But yeah, this is a pretty fun little program. I'm pretty happy with it. I'm going to go ahead and commit all this. Git DC. Let me go ahead and vim up my clang D and just delete that new line. Alright, build. Okay. This is just Excalidraw. Don't care about that. It's a really long JSON file. Okay. And there's no new line. Good job, guys. Drawui.c. I can remove those pound includes. Let me go ahead and do that. Source drawui.c. These are just for that scheduler stuff. Should be able to still make it here. What was this source tracer? Yeah, I don't have that there. Let's go down here. Just do a quick review. Standard IO, standard lib. I actually don't need standard IO. Actually, I do because of the string formatting. Okay, create window, destroy window. Some globals for the buffer and zoom level. So I'll probably encapsulate that global into some type of state struct. I feel like zoom, the selected buffer, stuff like that can be in a struct. Register buffer, that's fine. Update zoom, draw buffer. Draw bars, draw a circle, draw a loop. Let's see, before I log off here, is raylibs something I can parallelize, like do a bunch of drawing of shapes in parallel? Yeah. Raylib is built on top of an immediate mode style API that ultimately submits commands to a single graphics context. OpenGL, DirectX, Vulkan, backend depending on platform. These contexts are almost always thread-affine, meaning only one thread should issue draw calls. Concurrent, draw rectangle, draw circle, etc. from multiple threads will either crash, corrupt state, silently misrender. So the core rule is raylib rendering is equals single threaded. So that necessitates us designing around having drawing done on a separate thread than the UI and tracing, because I don't want to have the drawing, if it gets slowed down, like to mess up the UI at all, or to mess up the user input or tracing. But we'll cross that bridge when we come to it. We won't force that design. What can be parallelized, even though rendering is single threaded, you can still get real gains by parallelizing preparation work. Build draw data in parallel. Instead of drawing directly, you can split your scene into chunks: tiles, objects, UI, regions. Use threads to compute position, colors, visibility, geometry lists. Then merge them into a single list. Workers fill local buffers. Main thread merges, raylib draws. Okay, well, that's good to know. Command buffer style rendering. If you want more scalable architecture, worker threads produce commands. Main thread consumes command buffer, issues raylib draw calls. This mimics how real engines work internally. Raylib is simple, so it doesn't expose advanced GPU features directly, but under the hood, instancing, if you drop to raw OpenGL, sprite batching, shader-based work, particles, transforms. GPU shader. I think for this application, it doesn't really make sense to use GPU shader because it's meant to be portable. So like if I am going to port this to other platforms, I would need to retarget the shader for every hardware GPU I'd wanted to target. It just doesn't seem like a good idea. But this is interesting. I can start with raylib with this like very simple API, And then if I want to develop this program further, I can like continue looking at like scraping away the layers to get more performance. And maybe I do get down to like writing my own shaders at some point. But yeah, at the base of it, I don't really want to do that. Yeah, I mean, this is like what GPUs used to do. They used to render a full screen quad. Okay. Well, I suppose I should do my commit here and then log off. Been trying to do a commit here for like an hour. Okay. Alright. Cool. Git push all. I don't even have a remote for this thing. So I'm going to do that before I log off here. Let's go to GitHub. Oops. Trap. Let's create a new repo. VM viz. And create. This guy. Alrighty. Cool. All right, I will be on. See, tomorrow's Tuesday. Be on in the afternoon for my normal stream time. Today was a bit weird. I got on late, but yeah, tomorrow I'll be on around. I would say around 1 p.m. I think that's my normal stream time. Yeah, cool. All right, I'm gonna hop off here then. See you later. Bye.